Hello, everyone, and welcome to this episode. Today, we're tackling a type of problem that you're likely to see if you're working with solubility equilibrium. And it's a type of question that asks whether a precipitate will form if two dilute solutions are actually mixed together. So there's several steps to it. I've got an example here. It says, will a precipitate form when 50 milliliters of 4 times 10 to the minus fourth molar magnesium nitrate is added to 50 milliliters of 2 times 10 to the minus fourth molar KOH? And typically, if a precipitate is possible to form, if these concentrations are quite large, like zero point 0.1 or zero point 0.2 or something like that, precipitate will form very easily. But things get a little dicier when you have very dilute solutions. It's not a guarantee that a precipitate will actually form. And here we wanted to think about the steps we would take to do this. A lot of people would get to this type of question and maybe not even know where to start. So I've created a little list of steps that we can use, and if you feel like pausing the video and writing these down, you totally can. How to predict whether a precipitate will form. So first, we have to determine if there's anything that's insoluble that would have a KSP value that is small. Typically, these would be listed as insoluble on a solubility chart. We'll look at one in a second. And then once we determine if there's a possibility of a precipitate, we'll determine the new concentrations of reactants after mixing, because as soon as you mix them, their concentrations have changed a little bit. Put the new concentrations into a KSP expression for that substance, and we're going to be using the reaction quotient, determining the value of Q at this moment. And then we're going to compare Q with KSP, whether a precipitate will form if Q is greater than K, or if Q is less than K, a precipitate will not form. So let's get into it. Go back to our example. And it says, will a precipitate form? And we already read the rest of that. So first things first, let's decide if a precipitate is even possible to form. So I like to go ahead and just write out the possible chemical reaction. If I take magnesium nitrate and potassium hydroxide, I will swap the cations, and my two possible products are magnesium hydroxide and potassium nitrate. I'm balancing charges over here, and then I'll have to balance the whole equation. So my first question I have to ask is either one of these listed as insoluble on a solubility table? So let's get the solubility table over here and take a look at it. Now, I already know that potassium is always soluble and nitrate is pretty much always soluble. So it's not going to be the potassium nitrate. But if I find the junction of magnesium and hydroxide, I get something that is insoluble. So that's the product that I'm going to be looking for. So we'll label this one as soluble, and this one is insoluble. And so let's go ahead and check out its KSP value. I look on a chart of KSP values, and I find that the KSP value for this is 8.9 times 10 to the minus 12th. Okay, so it's insoluble on that other chart, but it actually is slightly soluble, and it has a KSP value. Okay, great. So our second step in determining if a precipitate is formed is to take our molarities and determine their new concentrations. So let's go ahead and do that. And you might be asking, why do we have to do this? So we have to do this because, yes, it starts out at 4 times 10 to the minus fourth moles per liter, but the instant I mix them, it gets diluted into a larger volume. And so I have to do a little dilution factor here. In this case, I'm taking 50 milliliters, and then it gets diluted into 100 milliliters total. So its concentration of the magnesium is actually going down to half of what it was before, 2 times 10 to the minus fourth moles per liter. And the same thing is going to occur with the OH. Again, I'm leaving the spectator ions out, potassium and nitrate. They're not going to do anything. And it's 2 times 10 to the minus fourth moles per liter. And this gets diluted down also to the same extent total. And that's going to make it 1 times 10 to the minus fourth moles per liter. Okay, so now I've got my new concentrations. Their ions are now hanging around in that solution at these concentrations. Will they form a precipitate? So what we're going to do next is think about the KSP expression. If there's magnesium hydroxide in the solution, it will dissociate slightly into magnesium and hydroxide. And the KSP expression for this would be magnesium 2 plus and the OH ion squared, because there's a 2 in front of that. And now what we're going to do is we don't know if this thing is at equilibrium, or if it's trying to get to equilibrium, or if it's gone beyond equilibrium and has to come back. So we're going to find the reaction quotient, the Q value. Under these current conditions, we're just going to plug in the concentrations that we have, 10 to the minus fourth, and 1 times 10 to the minus fourth squared. And when I work this out, I get a Q value of 2.0 times 10 to the minus 12th. Okay, so that's under the current conditions. These ions have this concentration, and the product of those concentrations, the Q, is 2 times 10 to the minus 12. But according to my chart, the KSP value for magnesium hydroxide is 8.9 times 10 to the minus 2. So Q is actually less than what K is. And let's go back to our chart. So you have to compare the Q value to K value. If Q is greater than K, then the ion concentrations are high enough that they will start matching up and dropping out of solution. But if Q is less than K, the ion concentrations are not high enough to make the product Q equal to K or beyond K, and so precipitate will actually not form. So Q is less than K, and if you're ever answering this type of question, you should write out no precipitation. No precipitate will form. And put a little heart next to your answer, of course, as we always do. And that's how we figure it out. That's the set of steps. There are probably other ways to do this, but that's the kind of the steps that make the most sense to me. So I have another one prepared for our pause the video moment. If you feel that you would like to try it, use your intrepid chemistry skills and follow the same set of steps to determine if a precipitate will form when 100 milliliters of 2 times 10 to the minus third molar lead nitrate is added to 100 milliliters of 6 times 10 to the minus third molar potassium iodide. Take a moment, pause the video, and see if you can get it. All right, and if you were able to do it, great. Here is what I came up with on here. And if you found out, just like me, that no precipitate will form, then we're on the same page. And let's run through it real quick. My two possible products are lead iodide and potassium nitrate. Potassium nitrate, again, is soluble, so don't worry about that. But lead iodide is technically insoluble with a KSP value of 1.4 times 10 to the minus 8. I did my dilution factors just like before and got my new concentrations, 1 and 3 times 10 to the minus third. Wrote out my dissociation equation, my KSP expression, plugged in my values, and got a Q value of 9 times 10 to the minus ninth, which is smaller, again, than the KSP value. So again, no precipitate will form. If this number ended up being higher than that, you would have a precipitate forming. Okay, so I hope this was helpful, and if you have any questions, you can send them to me in the comments or directly. In the meantime, I hope you see one of these around once in a while, and so you can impress your family and friends with your chemistry skill. And in the